This section is all about the relationships between angles in a triangle. The first relationship we have to know in any triangle is that all the angles A, B, and C are going to add up to 180. This actually becomes surprisingly useful in a lot of our proofs. The other thing to consider is adding an auxiliary line, which you've seen me to do before in proofs. But this idea that in a proof, you can, if we have a proof about a triangle like this triangle, B, A, C, you can add in another line if it helps you prove what you want to prove. We call that an auxiliary line. We have some corollaries, and a corollary is a theorem whose proof follows directly from another theorem. So two corollaries we're talking about in this chapter are the fact that acute angles of a right triangle are complementary. So if you have a right triangle, in this case, B is our right angle, we already know that A and C are acute. The question is, are they complementary? And we're saying, yes, they are. And we know that because if all of them together have to equal 180, and B by itself equals 90, we can subtract B or 90 from both sides, and we get that A and C equal 90 as well, which means, of course, that they're complementary. Likewise, the measure of each angle of an equiangular triangle is 60 degrees, which is one of the steps Andrew was trying to use today in his proof. This idea that all of the angles have to equal 60 degrees because it's an equiangular triangle, which is true, obviously, because 180 divided by 3, if all three are the same, is 60. We also have the exterior angle theorem, and the exterior angle theorem says specifically that an angle on the exterior of the triangle is equal to the sum of the two remote angles, which means that, in this case, the measure of angle 4 is equal to the measure of angle 1 plus the measure of angle 2. Here's why that works. We know that the interior angles, meaning angle 1 plus angle 2 plus angle 3, those all have to equal 180 degrees. We also know that angle 3 plus angle 4 has to equal 180 degrees because they're a linear pair. If those two things are true, then we can say that by substitution, or by transitive property, we can say that angle 4 must be congruent, or I guess congruent supplements theorem is probably more accurate, is congruent to angle 1 plus angle 2. Because the idea is angle 1 and angle 2 and 4 both are supplementary to 3. Therefore, by sort of congruent supplements theorem, they have to be equal to each other. Our last theorem for this section is called the third angles theorem. And basically, this theorem says if two angles of two different triangles are congruent, as they are here, then the third angle must also be congruent necessarily. Because remember, they have to add to 180 degrees. So if two are congruent, the only space left for that third is that same amount, whatever that amount is.